Hello, and welcome to 5-Minute Math. Today we are looking at representing place value. This is 4.2b Readiness Practice, the advanced version. If you are interested in exploring the intermediate or proficient versions of 4.2b or the Readiness Resource Practices, aligned with any other standard, you can find them using the link in the video description. So our first problem gives us the population of Houston, and you notice we're getting the population of Houston in word form, 2,319,119, and then we need to write that in standard form, expanded notation, and expanded form. So 2 million is my largest number. So just going to write a little place value chart here, and this is going to kind of serve as my standard form. And so I'm just going to write standard right here. And what I'm going to do is I'm going to translate the words. 2, and then this word million gives me my period or my family. So this is the millions period or the millions family. I'm going to put that in that teal. 319,000. So this is my thousands family. And then that last one is my ones period or my ones family, but we don't really say it. We don't say 119 ones. We just kind of leave that blank. So 2 goes in the millions place. And so I'm going to write that value underneath. I'll need that when I use my expanded notation. 319,000. So I'm just going to write 319 as if it existed on its own. And then I put that in the thousands period or the thousands family. So that is going to be helpful for me. 319,000. I'm going to write the place values underneath. Once again, I'll need them for my expanded notation. And then I've got my 119. So 119 is going to be my 119. That's my hundreds place, my tens place, and my ones place. So that's my standard form. Let's do my expanded notation. So expanded notation, what it does is we take each digit, 2, and we multiply it by its place value. So that is in the million spot, so it's 2 times 1 million. Sometimes you'll see it with parentheses separating each expression. You don't really need to with the order of operations. You can just leave it as 2 times 1 million plus, because we're going to take care of our multiplication before we add anything. My next one is 3. 3 is in the hundred thousands. And then we're going to add, what's my next one? 1 times its place value, 10,000, plus my next one, 9 times its place value, 1,000. Now we've got some 1s here, but we still need to multiply them by our place value. 1 times 100. Let's make that one a plus. You get a little bit, you have to be very careful with what you're multiplying, what you're adding. It's easy to kind of get a little carried away. And then 1 times 9, but actually that's reversed there. It needs to be 9 times 1 because it's 9 in the ones place. So that's my expanded notation. Then my expanded form is, I'm going to write it right underneath that. And what we're going to see is that it's very similar to expanded notation. Instead of writing each value as the digit times its place value, you're just going to write what the value of that digit is. So 2 millions, or 2 times 1 million, is 2 million. Right? So 1 million, 2 million. We're still going to add them. 3 times 100,000 is 100,000, 200,000, 300,000. 1 times 10,000 is just 10,000. 9 times 1,000 is 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000, 9,000. You can skip count by thousands. And then we just need to get our 100, our 10. 9 times 1 is worth 9. So they are closely related, the expanded notation and the expanded form. And that's how we're going to do that particular problem. Next, we need to generate 3 numbers. We need to have 8 digits in the number, and we need to have a value that has 7 in the 7 times 0.01, or that's the hundredths place. We need to write the number in standard, expanded notation, and expanded notation in word form. All right, so let's do that. Let's take our numbers, and so I need at least 8 digits. So 1, 2, 3, 4, 5, 6, 7, 8. And I need to have a hundredths place, hundredths, so let's just do that right there. And so let's write our place values here. That's the tenths place. That's my hundredths place. Ones, tens, hundreds. So there's a comma. So I need thousands, 10,000s, and 100,000s. All right. So that is my blank place value chart. Now let's write some numbers. The only thing that they tell us we have to lock in is a 7 in the hundredths place. So the rest can be anything we want to. And we need to write it in standard form, expanded notation, and word form. So here's my first one. It's going to be my standard form. And so we'll write that here as standard. I can write anything I want to. Now here's kind of a hack. You can make this the simplest problem to work out. What if I just put a 1 in the 100,000s place, and then everything else be zeros? Technically it works, because I've got 8 digits. So how would I write that in expanded notation? Well, I would write 1 times its place value. And what I'm going to do is I'm going to skip all of these zeros. You don't need 0 times anything. So we're going to do that, and then let's go ahead and go back to the teal. It's going to be 7 times that 100th. So that would work. It's kind of a strange number, a lot of zeros. Okay, and then the word form is going to be 100,000. And we say the decimal with the word and. So 100,000. We don't worry about any of the zeros. And 7 hundredths. All right, so that's going to be what we would put for there. And then we would just need to repeat 2 times. Right, so we need 3 numbers. And so answers definitely may vary. So I'll just go ahead and put that right here. What we're looking for is we're looking for standard form, expanded notation, word form. And the big key is, let's just make sure that we have a 7 in the hundredths place. That's kind of our one anchor. So you can add different numbers and expanded notation and word form to add to that. Let's look at our last problem here. I'm thinking of a number. We have a whole bunch of clues here. All right, so I'm thinking of a number. The 7 has a value of, now it's 7 times 0.1. So let me write this number. Okay, so I know I at least need a ones place and a tenths place. And I know this 7 is going to be right there. The digit 6 is value of 6,000. Okay, so let me go over here to the thousands place. And that's 10, that's 100, that's 1,000. And then I know I've got a 6 in the thousands place because it says it has a value of 6,000. Now, there's a 3, it has a value of 3 hundredths. You notice that's in fractional form. So I'm going to put it in decimal form. I'm also going to write these in fractional form. 1/10, 100th. Then I know my 3 goes right there. And then the number is between. All right, so 6,134, 6,859. So I need to do something with my hundreds, tenths, and ones to fit between those numbers. And then when rounded to the nearest whole number, the value of the ones digit is even. Okay, so when I'm rounding to the nearest whole number, I'm going to end up looking right here at my tenths place to see whether I round up or not. Since that's already above 5, I know that 7 is already going to make my number one more, which means I need to make my numbers here. I need to make this an odd number. So I need to like make that 1, because if I can make that 1, then that 7 is going to round that up to a 2. I need to make it an odd number so it rounds up to an even number. And then it needs to be between 6,134. So I'm going to make it 6,100. But you notice I don't have many options with 100. I can't put a 1 in the tens place, a 0 in the tens place, a 2 in the tens place, even a 3 in the tens place. But I can't put a 4, 5, 6, 7, 8, or 9. So this number would be between those two. So that number could work. And then if I wanted to generate another number underneath there, I could write 6,000. Let's kind of do our maximum here. 855. let's put, I can't put 59.73. I can put 50, if I put 58.73, that 7 is going to round that 8 up to a 9, so that's not going to work. So I put a 7.73. So I'm good here, I'm good here, I'm good here. And then when I round up, that 7 is going to round that other 7 up to an 8. It'll be even. So those are just two answers. And that's kind of a tricky one there. But there are many other answers that we can use. So I'll say answers may vary. So if you are interested in exploring the readiness practice resources for 4.2b for the intermediate or proficient versions, or for any of the other readiness practice resources aligned with other standards, you can find them by using the link in the video description.